Up next, we have a presentation that took many people, many hours to get here to the convention. It is first of all, Jay Leavoy will be presenting on the Gordie Howe International Bridge. Because this bridge spans from Canada into the United States, it was super appropriate for it to be here at our convention this week. Jay is currently acting as the Bridge Engineering Manager and Bridge Technical Lead for the Gordie Howe International Bridge Project, which aims to deliver the longest cable-stayed bridge in North America. Jay got his start in the construction industry out of university in 2009, providing engineering services to clients within Essex County. Since then, he has successfully delivered small to medium-sized projects to public and private clients before following his passion and interest in complex bridge structures and making the leap into project management within the Gordie Howe Bridge Mega Project. I'd like to thank Jay for being here, and please join me as we welcome him to the stage. Thank you.
All right, well, thank you everybody for coming today. Very much appreciate you guys being here. Obviously there's quite a few interesting things going on, not only with the convention itself, but you know, we're in the beautiful city of Vancouver, although it's been pretty gloomy, unfortunately, since I've gotten here at least. This presentation's booked in here for an hour. But I'll try and get everybody out of here as fast as we can so we can get back to the bar. God knows I'm going to need a few drinks after this. So today I'll be presenting, as Paula mentioned, on the Gordie Howe International Bridge, all things access related. So hopefully you guys will enjoy that. Maybe some of you know about the project generally. Maybe some of you know quite a bit. Obviously there's quite a few companies here today that have supplied products to the Gordie Howe International Bridge, whether it's the Canadian or U.S. sides. So we'll get into some of that here shortly. And Paula gave a quick personal bio for me, so I appreciate that, Paula. One other thing I wanted to mention was that I am born and raised in Windsor, Ontario, which is one half of where the Gordie Howe International Bridge is being constructed. So I'm sure many of you probably don't know much about Windsor, Ontario. Probably I'd say it's most famous for being Canada's most southern city. And maybe close second is late night talk show host Stephen Colbert referred to it as Earth's rectum. So also got that going for us. I graduated from the University of Windsor in 2009 from civil engineering. And then was a consulting design engineer for 10 years, and now I'm at the Gordie Howe Bridge, and as Paula mentioned, acting as technical lead for the bridge, engineering manager, and recently promoted to construction manager for the Canadian Bridge Site Civil Works. So with that, we can move right in. So here I've got a little bit of an agenda, give a bit of an overview on the Gordie Howe International Bridge project. There's actually about 4 distinct projects, not just the bridge. So as you could imagine, if you've gone across any land crossings, we've got the port of entry, which contains the tolls and buildings, inspection lanes, things like that. So we've got that on each side, obviously the bridge itself, and then some highway reconstruction work on the Michigan side. So we actually have like pretty much 4 independent construction teams working on those individual ones. So today I'll be talking mostly about the bridge, and then we'll move into the access items. So here, this gives you a bit of a overview, an aerial image that was stitched together quite recently of the construction site. So you can kind of notice the bridge the rivers passing under it. There's a bit of blue and then gray overhanging. So that's where we were at with the cantilever bridge construction maybe 3 weeks ago. So on the left-hand side, you'll see the tag there. It says Michigan Interchange. So that's one of the segments. So about 1.8 miles of the I-75 is being reconstructed as a part of the project. Also included in this segment are 4 local road crossing, basically bridges across the I-75 being completely demolished and reconstructed. There's also 5 new pedestrian crossings going in, and then obviously you can kind of see there the 4 brand new interchange ramps which will connect the U.S. port of entry to the I-75. I'll skip the bridge for a minute and move over, the U.S. port of entry first. I guess I'll get into that. There's over 300,000 square feet of building space in this port of entry, which is pretty significant. There's 36 inspection lanes and a number of toll booths, obviously. When this is finally constructed in the next year and a half or so, it will be one of the largest ports of entry in all of North America. The Canadian port of entry on the bottom right there, it's a bit smaller than the U.S. port of entry, not as much land, 22 inspection lanes compared to the 36, and about 134,000 square feet of building space. So a bit smaller, but more of the same there. So as it relates to the bridge segment itself, we're not doing any work in the water. Everything's onshore, so both of our towers are just close to each seawall, and we're completely spanning the Detroit River there. So the main span is 853 meters long, which once we're done constructing it will be the longest cable-stayed bridge in all of North America. It will also be the 7th longest in the world and the longest composite deck cable-stayed bridge in the entire world as well. So quite a few milestones will be reached and records set once it's constructed. So of course, as you could imagine with such a project, many unique challenges. On the bottom left there, you can kind of see the configuration of the bridge. The initial configuration will be 3 lanes of traffic in each direction, 1 multi-use trail, and then there are some shoulders there that are quite wide. So in the future, if they do decide that traffic demand calls for it, they're able to reconfigure the existing bridge to provide 4 lanes in each direction. There's some other items there on the bottom right that talk about the color, and it says that the tower was designed in the shape of a hockey stick. I'm not sure if anybody plays hockey, or I've played my whole life. I don't see it, but that's okay. So as you could imagine with the bridge, the tower has given us the most significant access challenge. So you can see here on the right-hand side, we've got the lower portion, which we call the tower legs. It comes with about 29 lifts of concrete, and then we've basically transitioned to the pylon head there for another 22 lifts. Most of the lifts are hollow in the pylon head. It's all like steel anchor boxes, we call them, which is where the cable stays are anchored to the tower. And you'll also notice on the left-hand figure there, we've got what we call the temporary struts. Those basically just prevent the legs from falling in on each other. So here you can see some photos. The right one is more recent, although you'll see in a minute that the U.S. tower is actually fully complete. But on the left-hand side there, you'll notice that we've got some jump forms on the top, so that'll be the first item I'll get into here, access related. But this basically shows you what the tower kind of looks like as it transitions from the legs to the pylon head there. And the tower is, once fully constructed, on the Canadian side, it is done. On the U.S. side, it'll be 720 feet tall. So in the city of Windsor, it will be the tallest structure by far. And in the Detroit area, if anybody's familiar with Detroit, there's the Renaissance Center along the water, which is a pretty significant monument in the city of Detroit. The tallest building is also exactly 720 feet tall, so they are the exact same height. Here, as I mentioned, the U.S. tower has been complete, and you'll notice on the figure kind of in the center and the bottom right, we've got a bit of an access platform there that they're installing in those photos. But they did finish that tower about a month ago, and we're working on the Canadian side. We'll be done the Canadian side in a few weeks, and all the jump forms will be dismantled and removed. So the jump forms provide all of the access at the tower head, like where we're working basically. They provide a platform for rebar work, obviously concreting, all that good stuff. There's four levels to this. You'll see here on the right a bit of a figure. You've got the very top platform, which is at the top of the lift that we're working on, and then kind of the lower platform, not at the bottom but more in the middle, provides the top of the previous lift, so that you've got full access to the ongoing work, whether it's solid or hollow, for the rebar works, embeds, all that stuff. And then you'll notice at the bottom, there's another platform. That's where like all the jacks are and stuff. So these jump forms are self-climbing. They basically hang on some embedded items and some threaded rods, and the jacks, they all work together to jump this thing to the next lift, and then they hang on to new embeds. So it's consistent. It provides, the same process over and over. The sequence is identical, which obviously drives efficiency and productivity. So these things were designed and fabricated in Australia by OM Engineering. So they've been great to work with. And you'll notice here, we had a unique challenge where obviously we had independent and separate jump forms for each tower leg, which you can see on the right photos. And then obviously once we reached what we call the crotch of the tower at the top of the legs, which is where we had to merge the jump form. So there's a lot of steel work involved there in order to do that. But we got it done, and it worked out well. So these jump forms provide a very significant access point to where the majority of the work's going on in the towers. So we've got a bit of a video here. I'll show you some drone footage of the jump forms over the years. How does it jump? So there's jacks basically all under on the bottom, and they grab onto a threaded rod that's hooked onto some embeds in the concrete, and it just basically jacks on the threaded rod and pulls it up, and then you replace those on the top of the next lift once it's cast with concrete, and just on and on. Yeah.
How much time for the run one pylon all the way? I was wondering how much time it took from the start of the pylon to, you said the U.S. side was completed, so.
Yeah. So we installed the jump forms on the U.S. side. It was February, must have been 2021. And they just finished last month.
So, yeah, almost 3 years, huh? Getting close, 2.5.
Yeah. More or less.
And how much lift was one jump on the lower legs?
So the lower legs were just under 5-meter lifts. And then the concrete head, because of the anchor boxes, are a little bit different. They're a little bit smaller than that. So you can see here, this is one of the segments of the video showing the guys getting the jump forms prepped for the merge. So that's it for that video. So I will say I've got, I think, 5 videos on this. If anybody has any questions, that's a perfect time if you want to talk. There's no video or audio, sorry, on the videos. So there is a bit of a Q&A session at the end as well. So feel free to ask questions just about whenever you want. So the next item I've got here is the temporary elevator. This particular hoist provides the main access for the main span deck and the entire tower. So this temporary construction elevator, as you can see, was supplied by the great team at Fracco. So I know Fracco's team is here and has a booth, so I encourage everybody to go talk to Shannon and Francois, Julie, and Yannick, and those guys, a great team to work with. So they provided the temporary elevator for us, and there's a few unique items related to this elevator in our tower that are of note. So this particular elevator is Fracco's SEH model, and it's got, I think, 6,000 pound capacity, which is about 30 people. So it's pretty big. And you can see here, one of the questions I believe from Eric was just how much this thing jumps, right? Or how long the tower's taken. And we talked about this thing jumping right in automatically. So as you can imagine, the elevator and the mast is going to be stationary. And as this jump form jumps and begins to move up, we've got what Fracco's design and calls rolling ties, which is a very unique and cool feature. So basically it ties the elevator to the jump form and locks up. And then when we'll move to this one here. This is a little bit of a shot on the rolling ties. Once the tower jump forms are done jumping, we basically lock the rolling ties and continue to extend the elevator and move on to the next lift. So it's all pretty standardized, and the sequence, obviously at this point, U.S. tower's done, but Canadian side, we're cruising along, and everything's moving along very, very smoothly. So just go back here for a second. The elevator does land at the very top of the jump forms. So that's the top landing, and obviously once the tower's complete, it will land at the top platform. But there are 3 other landings, including the actual bottom and base. We also have a landing at the deck level, and then there's also one at the crotch where we've got what we call platform 5. So that's one of the items that'll be coming up as well. One of the other unique design features that we took advantage on the Canadian side, at least, was integrating our concrete slick line into the elevator mast. So one of the questions that I get a lot is, how do you get the concrete up to the top of the tower, right? So in this case, on both sides, we've got a massive stationary pump that's at ground level. It's got a hopper, concrete trucks just back in, unload the concrete into the hopper, and then this pump pumps the concrete all the way up through this concrete pipe, and it gets distributed into the particular lift with what we call a mini placer. It's like a reciprocating arm. But on the Canadian side, we were able to integrate the concrete pipe into the actual elevator mast, which is pretty unique. So I've got another video here which will show you some more information. Show you a little bit more on the elevators. So it's similar, it's just not integrated with the elevator itself. So they had to do separate embedments, separate ties from the concrete pipe right to the tower. So it's completely independent of the mast, but very similar concept. We were just able to, utilize the mast itself for support, which made it a little bit more efficient.
This is work. Hey, I'm sorry. You mentioned the crash a couple of times. That's where the two legs come together?
Yeah, the crotch.
The crotch, okay.
Yeah,
I thought you
that's where the legs come together. That's right.
Well, the formwork kind of crashes into each other right there.
That's true. It does crash into each other as well.
Yeah, that looked like that had to be a pretty tough transition, getting the two forms to come together into one.
Yeah, it took some time, a lot of, steel cutting, welding, all that different stuff, but we worked with the supplier on a plan beforehand, and it worked out pretty well. We had some electrical issues on the Canadian side once joining everything, but that all got straightened out, and obviously we're moving on. Yeah, so there's, you can see one on the leading edge there, and then there's a few more back at the tower. I don't know if you could see them, but yes, we call them CATs, Construction Access Travelers. So those are provided by California Scaffolding. I'm not sure if they're at this event or not, but yeah, so there's 3 on each side. One at the leading edge for obviously the work and stick building, the rest of the main span, and then some trailing behind for paint touch-ups, doing some of the other craft work that leads behind electrical, our fire suppression system, all that different stuff. So the next item I've got here are the permanent tower elevators. So we do have 3 permanent elevators in each tower. These are also provided by the Fracco Products team. So if you recall, I don't know if I can scoop out. I can't go back very easily. If you recall one of the initial slides I had there, it showed the legs and the pylon head. We basically have one elevator in each leg above the deck level and one in the pylon head. So at the crotch or inside of the soffit panel, that's where the inclined elevators within the legs land, and then you're able to just go up a few sets of steps there and get into the vertical elevator if you want to go up through the tower. So the permanent elevators in the tower legs are mainly for access only. They basically start at the bottom and they take you to the top of the leg, and that's about it. They don't stop in between. There's also permanent platforms, ladders, and all that stuff as well in the tower legs, in addition to the elevators. So those are primarily used for the inspection and some of the maintenance of all the electrical items in there. So this gives you a little bit of an isometric of the tower head. So I mentioned at one point we've got anchor boxes, and the tower head is hollow as well. So that yellow box there is the anchor box. And then you can see what we call the vectors coming out each side. That's where the stay cables come in and are anchored. And then the hoistway is more of the pink rectangle there projecting out. So that's where the elevator is located in the pylon head. So there are a number of different platforms in the pylon head. The elevator will only stop at the second from top, which is where the last cable stay is, and also at the very first cable stay, and then obviously at the bottom too. So there are only basically 3 landing spots for the vertical elevator as well. The permanent access platforms, as I mentioned, there's a number of them, 29 to be exact, and the permanent elevator basically travels through all of those. So it's pretty typical, just some I-beams and some grating, nothing too crazy, some handrails, and then there are some hatches, one for access, which doesn't show it there. That one shows, well, the personnel access, worker access, but you can see here there's one that has a ladder coming out, and then there's also a material hatch there. There's like a little overhead crane at the top of the tower that'll always be there, and people will be able to bring materials up to each level through that access hatch. So I also mentioned the temporary platform at the crotch level. So this is what we call platform 5. This is also a very critical access point for the bridge construction generally, but more specifically to the stay cables. So you can, well, there's some better photos coming up here, but you can see on the top right, there's some scaffolding on the actual platform, which provides access to the mast climber for the stay cables. So that's another item I'll get to just here in a few minutes. So here's a little bit of more of a figure on the platform 5. It does provide access around the entire tower system, in between the legs as well and around. So like I said, this provides critical access and material storage for the stay cables. All the good things are up there, the sea cans, and obviously the important porta-johns. So I've got another video here. It gives you a little bit of a better view on the platform 5, and I think at the end it'll have the scaffolding and the mast climber there.
One of the questions I have is that red platforms there, that looks like it's just made of structural steel?
Yeah, that's right.
Okay.
Jay, that looks like a long walk for the crane operator.
Yeah. Well, luckily they can take the elevator up to a certain level, and then you can see what we call the tower crane ties. There's a perfect view of one of them. I think that's tower crane number 4. And they can actually walk across that. Then they have to continue to climb the rest of the way, but it's definitely better than climbing up from the ground level.
And Jay, did you have a team that was working on the U.S. and the Canadian side, or how did that dynamic work between Canada, U.S., bridging a bridge together between two different countries?
Yeah, that's a great question. We basically do have 2 separate teams. Obviously, the bridge is more or less symmetrical, so we do work very closely together, of course. But we do have different engineers from across the world, especially our lead engineers that, they have different opinions and, different preferences and things like that. So we do things slightly different depending on what's going on. But yeah, there's one team on the U.S. side, one on the Canadian side. Myself personally, because I'm in the office, I run all the office stuff in the engineering department. I cover both bridges, U.S. and Canadian. But as it relates to the construction teams, they are separate.
And who was doing the construction on the U.S. side and who's doing the construction on the Canadian side?
So we've got a bit of a unique setup. So the joint venture general contractor that's designing, building, and ultimately delivering the project is called Bridging North America, which is a joint venture between Fluor, Dragados, and Aecon. On the Canadian side, we're BNA Canada, BNA Constructors Canada, GP. On the U.S. side, it's BNA US JV. Basically, We're all Bridging North America. All the employees are hired and employed by the three parent companies, but technically BNA US JV is a subcontractor to BNA Canada, and so they basically run all their stuff through BNA Canada. So the headquarters, let's say our project director and all the lead staff, our senior leadership team is located in Canada. But we're, on the bridge team at least, we're self-performing most of the work. So very little of it is actually subcontracted out for the actual work on site. For some of the other segments, like the ports of entries, the large majority is subcontracted. Like the U.S. port of entry is completely subcontracted, and same with the Canadian port of entry. The I-75 is more self-perform, similar to the bridge. But the bridge team does self-perform the large majority of the work. So here's, I mentioned in one of the pictures also showed the very, very top of the tower platform. The picture at the time showed the completion of the U.S. tower. So this is the design for that. This is where the temporary elevator will also land. The U.S. side has it complete. The Canadian side will have it soon. And so now we get into the mast climber. So this is provided by Climber. Not sure if they're present at today's conference or not, but they did provide this to both sides. So we've got two on each tower, one on each face of the tower where the stay cables are coming out. It is a pretty cool mast climber. It's modular, so there's a bunch of different platforms that flip up in order for the platform to actually travel vertically in between the stay cables, and also have these platforms fold out on the sides in order to gain access to all sides of the stay cables. So it's a pretty interesting piece of equipment, and somewhat similar to the temporary elevator. Whenever we jump the tower jump forms, this follows closely behind extending the mast as we go up with the concrete lifts. So another noteworthy item there, for the entire bridge, both towers, we've got 216 cables. So there's 54 on each face, which is what one mast climber is used to help install on the exterior face of the tower. Here's some more photos of the mast climber. So in addition to platform 5 there at the crotch, there's also some scaffolding you'll notice that provides the access from the platform up to the actual mast climber. So that's obviously a pretty critical piece of access in order for stay cable installation to continue. Yeah, so all three of those photos basically show just different views of that. If anybody has any questions, I encourage you to ask, because I'm running pretty quick through this presentation here. There's a de-icing system on it. Basically, the cables will be heated, essentially. There's also, they're designed in such a manner where the ice won't form and fall. But there is a de-icing system on it that actually prevents ice from forming.
In that one shot previously, it looked like that crane was holding its own tower section to do a jump.
Yes.
So it self-jump?
Yes, it does. Yeah. Not sure if I can, yeah, I can't pause, sorry. Let me go back. So yeah, you'll notice at the very top of the tower crane, there's a little bit of a more robust section you'll notice, so what happens is the tower crane can actually, it jumps itself and leaves a complete section open. And yes, it picks up different mass sections, brings it in, and then it gets installed by our guys, and it can continue to jump one section, brings in another section, and it does basically self-jump the tower crane. So it's pretty interesting.
I got a question. In regards to the Fractal rails, what degree of tilt are those rails?
The rails, as it comes up the curve of
Yes.
the tower,
Yes.
I honestly have no idea what the angle of that is. The guys from Fracco may know, though.
Yes. What's the angle? Yeah. Yeah. Is that the maximum allowable angle that you can go, 10 degrees, for the Fractal system? Thank you. Here, hold, wait.
So, yeah, the car is actually self-leveling while it's going up, so people will not feel, the angle. So we have an hydraulic system with the inclinometer system with redundancy that keeps the car always at level. So we have a certain speed on the angle one. When we get to the curve, we reduce the speed to be able to adjust. And then after that, we just kept going straight. Welcome.
Yeah, thanks, Francois.
Is there any maintenance requirement on the cable?
There shouldn't be any. They will need to be replaced. So the design service life of the bridge overall is 125 years.
I'm not gonna worry about it.
Yeah. Yeah, I don't think any of us will be around that long. So, but the stay cables I think are like 60 years or something like that. So the stay cables will have to be replaced at least once within the life of the structure overall. So the next item I've got here is the underbridge maintenance gantry. So this will be installed at the very end of construction, just prior to bridge handover and bridge opening. So the purpose of this particular device is just to provide access for maintenance and inspections along the bottom of the bridge. So we've got what we call gantry rails, and you can see those are the 2 points of which the UBMG attaches to on the underside of the kind of the brownish grayish floor beam there. So this is a pretty unique structure as well. You can see in the top right figure that the UBMG there is retracted completely, which is a requirement. So you'll notice what we call the corbels, or the kind of the overhangs from the tower legs, which is what the deck sits on and where it bears. So the UBMG does span the entire main span. It basically travels from our anchor pier, which is way back 400 meters into shore, and it travels all the way to the center across the river. And then there's one on the US side, and they can basically cover the entire length of the main span bridge. So it does retract to come through not only the piers, but also the tower, which is shown there on the top right. And then on the bottom right, you can see it extended, and also with the stair towers that basically telescoping stair towers that provide access to the deck. So it's a pretty cool structure.
Is that like a scissor lift
Yeah.
on the ends?
Yeah, more or less.
How complicated is that bearing pad on each end there? I mean, that's a lot of bridge span resting on that bearing pad.
Yes. Yeah, the bearings are pretty big. So we've got, I can't remember the dimensions. They're provided by DS Brown out of Ohio. They're disc bearings. But yeah, they're very, very large disc bearings. As you say, I mean, it supports basically the entire main span, right, in both directions. So yeah, it's a pretty significant vertical bearing. And then there's also bearings, you can tell, like in between the tower leg and the floor beam there. So we call them, like, they're almost like bumpers. They're not even bearings. like traditional bridge bearings. They're an elastomeric bumper almost. So that provides kind of the support for the bridge in between the tower legs. And then if you could imagine if you were to flip these views around like 90 degrees and you're looking at just the tower legs behind each other, the bridge can also move longitudinally, right? So we've got on the US side, we've disc bearings as well, longitudinal, so there's brackets that come off of the superstructure. And then those bear also on the corbels. And on the Canadian side, we don't have bearings, we have lockup devices. So those are like shock, also called shock transmission units. In the event of like a major wind event or earthquake or anything like that, those things lock up. And under normal service, they just allow thermal expansion and contraction of the bridge.
You mentioned the bridge turnover. Is there some sort of approximate date on bridge turnover?
There is. I don't know how much I can say. I'm sure everyone can imagine, you know, we started construction in 2018, has spanned through the entire pandemic, right? So there's a lot of legal things that go into that with, because we're working for the Canadian government, right? So that's never that great. But so basically,
maybe unofficial date.
well, yeah. So I mean, our contract says November 2024. We're probably something like 6 months delayed. So we're working on getting that, you know, through a change order with the client all ironed out and stuff like that. So we're getting close, but yeah, it'll be into 2025 for sure at this point.
Will it have a wind limit like the Mackinac Bridge?
No, there will not be a wind limit. All right, so another overhead shot, plan view of the UBMG. So it's a pretty big structure, 6 meters wide, spans the entire bridge length, which is width, which is 37.5 meters wide, and obviously a bit wider than that for the stair towers to come up. So I would imagine it's something like 40 plus meters long. Here's a bit of an isometric, it shows you a better idea of it extended with the stair towers as well. Obviously, it's got a trolley system for it to move, motorized trolley system, generators, control panels, all kinds of stuff on here. So it has been designed to support 15 workers at one time, plus a few thousand kilograms of live load, whether it be paint, tools, any type of materials like that. So the next item here, I mentioned the corbels a couple times. So that's what, as I mentioned, what the bridge superstructure and deck bears on for each tower. So in order to construct those, we obviously built the tower legs, went well past that, and we implemented this false work system to provide access to the areas where we needed to begin doing the rebar and concreting of the corbels. So this was a pretty interesting design, but unfortunately there's no other access to these things other than climbing up ladders and platforms within the tower legs. So yeah, it's never fun having to do that. There's many times where we have inspections on both sides too. You have to climb down, climb up the next one. So I'm happy to be done that part of it, that's for sure. Here's some more photos. The first one there on the left shows some scaffolding on the corbel false work. This was all set up. I think the corbel is in that photo.
It looks like it is.
Yeah, so Eric, you asked about the vertical bearing. So that's the scaffolding system that was set up in order to install that. And then you can see the bottom two photos, or actually the top right photo, you can actually see the bearing is actually installed there. And then the PTFE sliding material is protected. And then on the bottom two photos, you'll see what we call the pier table erection, which was the very first primary pieces of structural steel to be placed. The floor beams, first few girders, things like that. So those are all locked in place and on top of the bearings, and that's how we started on each tower. Okay, getting close to the end here. I've just got a few more slides, just showing some miscellaneous items. So here, this is our anchor pier, where we had some significant false work and scaffolding, formwork there at the top. And we also had to do similar systems for our approach bridge, which is all typical concrete pillars or columns with a concrete cap across the top. So we utilize similar system here, which is the next slide. This is actually the approach, one of the approach pieces of substructure that we just completed a couple months ago. And that's it. So appreciate your guys' attention very much. If you have any questions, open here too. If anybody wants to come and chat afterwards, maybe not about access or anything, I'm open to that as well. So again, I appreciate your guys' time today, and I look forward to speaking with some of you afterwards. Thank you.